Hi, I'm Leah Sherwood with Science and Medicine Group. I'm reporting from the American Association for Cancer Research in New Orleans. I have with me Dr. Beatrice Knudsen. Hello. She is with the Huntsman Cancer Institute at the University of Utah. She also leads a lab at the university, which is focused on such areas as computational pathology for biomarker development. Dr. Knudsen spoke today on Pathomics and next-generation pathology tools for cancer research. Welcome, Dr. Knudsen. Thank you for joining us.
Thank you.
Before we talk about the session today, can you tell us a bit about your lab?
So my lab at the University of Utah and the Huntsman Cancer Institute is at the interface between pathology and computer science. The laboratory also includes both pathologists and computer scientists who work in the area of computer vision. Many of them are graduate students at the University of Utah, and they develop new software tools that can be deployed to pathology images. We also require a large computing infrastructure that is provided by the Center of High Performance Computing, which supplies the computer network for the university. And this is where we house the images that we analyze.
Thank you. Can you describe Pathomics? That's what you spoke on today at the session for our viewers and the benefit it offers.
So Pathomics is an emerging science, and it uses the methods developed by experts in computer vision and applies these methods to pathology images. And what these methods, which are basically software, accomplishes is that the image can be described as a set of numbers. So an image becomes a very large data set. The features that the computer sees in the image are patterns that have to do with tissue architecture and also specific details of cells in the tissue. So these features are hidden to the most part to the human eye, but the computer can learn them. And Pathomics is really the science behind the analysis of those features.
Okay, so speaking of computer vision, let's turn to AI. What clinical advantages can AI provide for pathologists today?
So there's a number of clinical advantages, but none of them are in the clinic today. Okay. So looking into the future, computers can help pathologists to become more efficient by taking over some of the tedious work that pathologists have to do. For example, counting cells in tissues. Computers potentially can also screen out slides that are not informative for the diagnosis, so that the pathologist can really focus on the very critical tissue that they have to examine to come up with a diagnosis. There's also a number of other advantages, such as getting together with colleagues to come to ask questions to make sure that the right diagnosis is provided. And altogether, we think there is also an advantage in bringing automation to pathology, to anatomic pathology and histology in general.
Okay, thank you. So how can pathologists contribute to these AI projects and even getting them into the clinic?
So there's a number of ways pathologists can contribute. So the talk I was giving today really showed at least two examples how pathologists can contribute. So one is to annotate the images. What that means is to circle in the image what the computer should be learning. The second part is to interpret the output of the computer, so to make sure that this output is really correct to the eye of a pathologist.
Yeah. So speaking of the session, so the session focused on prostate cancer. What are the specific advantages that Pathomics can contribute to this application?
So prostate cancer has been at the forefront of digital pathology development for so two major, I guess, directions that have really happened in the last 6 months in prostate cancer. So one is that we got the first FDA approval of an algorithm to find prostate cancer in pathology slides. And that was really a breakthrough. The second is a large worldwide challenge that was initiated by the computer science community in the Netherlands.
Okay.
We learned from this challenge that it is very quick to develop computer algorithms and that these computer algorithms can reach the accuracy of a pathologist.
Okay, thank you. Okay, so in looking to the future, what are you most excited about Pathomics or digital pathology or anything computer vision pathology?
So I'm actually, I got into this field about 10 years ago. And at the time, my idea was that if we can enumerate tissue architecture, that we can understand the mechanisms that cause the tissue architecture. And these mechanisms are going to be mechanisms of disease development and progression. And so I'm still very excited about that opportunity. But there are also many other opportunities for digital pathology, especially in the clinical domain. What the study that was performed for the FDA approval showed that the algorithms can help community pathologists to be as accurate as subspecialty trained pathologists. It also showed that it can make the expenses in pathology less by providing less need for ancillary studies that are normally used for diagnosis. And eventually what we hope is that we can use algorithms to replace some of the very expensive genomic analysis that is currently done with patient tissues in precision medicine.
Okay. Well, thank you so much for joining us, Dr. Knudsen. We look forward to seeing all the great work you do in the future. Signing off from New Orleans, I'm Leah Sher with Science and Medicine Group. Thank you.